Just maybe. Maybe the Russian ringer can self-run already. Maybe.
Well, I think Gerald's doing the same thing. He's doing his in cold, so he doesn't have the resistor, and he's pulling through the negative. And his is real close to self-running as it is. It'll run for a few minutes after the fact. He's pulling in some of the environment into it. So it holds the energy inside and doesn't dissipate right away.
Yep. We call it the knife edge. He's at the knife's edge. It sucks being there because you're so close. But it's not real far away, but like you could be surprised. Like you might throw one cap in and throw it over. Like that's what could happen. So
yeah,
as he just keep playing with it. Yeah. Cool. I can't see the comments on my phone. Let me look again. Oh, yes, I can. Maybe. Yes, I can. Okay.
So let's see. Hold on.
Oh, that's a lot, man. I haven't even.
Oh, yeah. There's always a lot there, man. So, what else do we got going on, man? You said you were doing another generator?
Let me get back to the. Oh, here we go. No, I don't. There it is. Okay. Yeah, the diesel generator, the inverter project. I've always wanted to do that because making a DIY generator is pretty simple. It's pretty straightforward, actually. And I know a lot of people search for it because I see it in the YouTube algorithm when I look at it. So, and let's see. I'm also doing off-grid stuff. I'm gonna try to convert a rooftop RV air conditioner into a DC air conditioner that has a heat pump feature. It's pretty simple too. So that's coming. I'm gonna video that, and then let's see, what else am I gonna do? I mean, I have a list in there. I don't want to go through everything because it's part of the surprise, but it's a lot. Yeah. I kind of stopped doing some of the other projects because I wanted to do. I have a good idea with what I'm doing right now, so I think it'll be pretty good. I think the viewers will like it.
What on?
You can pull it up if you want, the diesel inverter, because that's it's going to be almost like a teaching tool. It'll be a perfect project for someone that has the mechanical experience to kind of do it, and then go from there. Start learning from something that's simple, that is effective, and can help you in life. Like it can generate power if you needed to. You could charge a battery bank really quickly with that.
Okay, give me 1 second.
Yeah, mine should be able to weld too. I should be able to weld with my big one, because I'm going to have a lot of DC available. I should have. Well, I have to see. Yeah, I could turn it into a welder too, like a switch mode. Nothing. Yeah, that one is that's the baby. That's my little one. But yeah, you can play that.
That's a little one?
Yeah, it's my little one. I have two. But yeah, that's a cool one. It's on my car still.
Well, let's play it. Let's see what it is.
Yeah.
All right, everybody. So today I just wanted to show you the muffler. I had to do it. And there was a good point. I had a commenter say something. He was like, diesels breathe better if they're open. Why don't you leave it open? It's going to be more efficient. And I'm like, that's true. But my thing is I don't want, for a 300-meter radius, this thing to stick out like a sore thumb with noise. So that's why I decided we need to fix the noise a little bit. I'd rather it be like 100, 150 yards than 300 or more, that you can hear this. You know what I mean? So we need to dampen it a little bit. So the way I intended to counter that, and that's the old one that I built for this. This is a 4-inch. That was a 2-inch. This is 4-inch. Where's my light there? Right there. Okay, so it's all stainless. This is just what I happened to have. This tubing is also stainless, but it's thin, and I just pinched the end. I didn't care to weld it really, and I didn't have a purge. I don't have a purge set up, so yeah, just holes on both sides. And you can be really creative with a muffler. There's a million ways you could do this. You don't even have to make it nice like this. Like you can just you can get like a small car muffler and adapt it to this. And so one of the things I did, that's a 1-inch tube. Now, their tubing wasn't that big. You can see my tubing is a little bigger. I'm trying to see where I'm at. There it is. Yeah. So my tubing's a little bigger than theirs. I actually had to squeeze mine down to fit theirs, so it should be okay because I'm oversized slightly. Got the coupler on. Now I had to adjust it, you know, and line it, and now this rubs a little bit, so I gotta fix that alignment. I can do it. That's why I like this Lexan too, because it's easier to see your motor, so you can align it. Because you do have to adjust it slightly, and I moved it, and so of course it's off. And I think it's crooked a little bit too. I need to straighten it because when I loosen this side, I think my frame is very slightly. It's not necessarily crooked. It's just very. It doesn't take much to throw this off. So I had to oversize the holes for adjustments. So it looks pretty square. It looks like it might be off in the front. Like I need to scoot this that way slightly because I think this didn't shift towards me because I put it in a bind to try to get it as close as I could without opening the motor holes up, and then I realized I couldn't do it. So I opened the motor holes up. Now we're good. But fix that, and then I'm gonna finish this. This is the packing. It's ceramic. I'm pretty sure that that's ceramic packing. It's gonna go around on the inside. Then I'm cutting this off. Get back so you can see it. Cutting that off probably. It's not gonna be very tall because this is way taller than I wanted it to be. But I'm like, straight up will work because it's compact anyways. So yeah, I'm gonna put that. I have another cap, and then that tube will go down. And I might pinch it and put holes in, or I may just leave it open because it's going to go in there eventually. But this is going to baffle with that packing. It's going to baffle the noise much better. It's probably still going to be a little loud, but that's going to dampen it a lot, man, especially from a distance. So I wanted to show you all that. And yeah, this one's basically, I had no packing. I should have put something in there, but it would have maybe helped a little more for sure. But this only dampened maybe, I don't know, 5%, 10% of the noise, which it was barely noticeable. When I started, I was like, oh man. The good thing is I made a nice snorkel for it so water can't get in. That's removable, and I colored that intentionally with a torch. I didn't color this one. I'm just going to leave it chrome or stainless. So, and yeah, that's a decent thickness, so it shouldn't rattle or anything. And this is solid welded, so it shouldn't rattle. And yeah, this should be much quieter. And if it's still, I'll tell you what, eventually I am going to take this motor apart because I want to look. That exhaust one of the bolts was loose, by the way. So you need to check your stuff if you buy one of these. Check all the bolts, make sure stuff's right, because I think they kind of hurried up and assembled it over there. They didn't care about torque settings too much. They didn't care about even drill the holes out on the bottom. It was still like casting nasty. So you have to drill your own holes. So I want to look in there and see how out of balance that motor is and see if I can balance it. You know, I can do it on the bench myself. I could see if it's out of balance, and I can balance it better if it is what I think it is. Because I think it's kind of like a lawnmower. Like they don't really care about, even though Briggs and Stratton and then they balance it a little better than that. But this vibrates a lot, and even the reviews say that. But it runs good, and it's got good 2.5 horse. I think. I don't think it's 3 horse, but yeah, I still got to disassemble it again, because I got to put the other generator on them. I'm putting a second one over here. Holes are already there. And then I got to rewind it, so that's going to take a few days. And use an ink pen. Take the inner cartridge out of an ink pen. That's how you can wind motors. You can even open that hole up on the end of the pen. It'll save your hands, trust me. Oh, I had blisters for weeks when I did this, and this took me 2 days because I was very meticulous, making sure the winds were right and the way I brought them out, all out. So, and I'll have to rewire that because I can't remember what I did. And is some open wires, so I have to look. I think it might be the neutral. I'm pretty sure I did that star, and it was like 3 pairs of parallel or something. 2, 3, I can't remember. It might have been 2. Or I think I might have seriesed all of them. I can't remember. I'll have to get into it because that's going to matter, because I'll have to wire it for the voltage I want. Because this, I think, I got a couple of different boards. I found a 1500, and I'll show you when I get them. But a 1500 watt buck down that is 94% efficient, which isn't bad. That's their best. You know what I mean? It's probably really like 90, 91, but it can take up to 95 volts, and it bucks down. It has to be at least 20%. So if you pump it in 95, it's almost 100 volts. So you're getting out at least 80 volts, which you don't even need that much DC. If you want to make a little inverter out of this, you just get a 48 volt inverter. That way your cable requirements is low, and everything runs a little easier when you can use the highest voltage you can but you still need to be able to maintain most of your power conversion. That's the key to all of this, man, to make a really efficient stuff. So, and we're gonna see if I can beat the efficiency of modern inverters.
So hold on. So you got this motor and you're running a generator, right? How much are you pulling out of that thing?
I'm shooting for 1,200 watts, but I could get at least 1,800 watts, but probably about 12.
And how many? What's the breakdown on your amps to volts?
I don't know yet. I'll probably go 48. So the generators will be adjusted to where they could probably put out about 80 or 90 volts at maximum speed. I'll have to see, because I may switch it in, switch series. Switch it to where I could switch from delta to star to increase or decrease the voltage a little bit on the speed. I want to make a board that does all that automatically, so you don't have to worry about it. But yeah, so you can switch it like that if you want to do a low speed, because that's what I was shooting for, was a lower speed generator, because it's very efficient. If you can idle a diesel or run it about 12 to 1,800 RPM, you get way more efficiency out of it. So that was part of the deal, because the inverter, you can vary this idle speed, you can vary everything, and you're already using DC. Because I wasn't going to put an inverter on this. You could put a small AC inverter on it and run it straight off the generator, but I'm not going to do that, because I already have a battery bank that has an inverter. So I'm just going to charge the batteries. You know what I mean? As a backup, because you can still, put it into your bank, and it's even more efficient because you're not converting it again to AC. You lose 10% there, total efficiency, because you got to add your efficiencies up when you add a stage. You know what I mean? You add an AC stage. Yeah.
Well, that was pretty interesting. By the way, in the comments, we were talking about Tesla and the dynamo. Just so everybody understands this, the dynamo was basically a generator that he had, right? And he ramps this thing up, and it acts like your ZVS and your Tesla coil. So it's slamming hard into a number 2 coil that goes in there. Now, he can adjust what's coming out of there by putting a rod through the center of this thing. What it does is it backs it up, and then as soon as you let the rod out, it lets it all flow. So you're getting a massive jump of energy at one time, right? You spark gap that with a quench on it. So what it does is it allows it to go through, and then you stop it right there dead in its track. This thing spikes to the roof, and you have a massive amount of energy coming out the other end. That's why he was using that dynamo. It was in Linderman's book that he was talking about it, and it was way more powerful than anything we're using right now. So I just wanted to answer that real quick. I was talking about it.
Oh, yeah.
I love talking about Tesla, man. He's got so many cool things, and just when you think you found enough, you haven't.
Right. Well, the dynamo is a very interesting topic as well, because that's what was the original energy generations, and it was DC, and that they had giant ones all over. And then the question is, how far back were they actually using them compared to recorded history? Because there seems to be evidence of it being massively used all over for a lot longer, essentially.
Oh, absolutely. Yeah, they're way back. They had everything. They all verified each other, which I think is very important. You got Tesla verifying Faraday, and then going back to Helmholtz, verifying each other, you know what I mean, with different experiments back when the time when they developed everything. So I thought it was fairly interesting when Tesla started describing everything as gas when he got it out to his radiant field, because that's exactly what I'm finding and what I'm doing is everything radiates like gas, and you cannot compress it. I haven't found something that besides mineral oil that's compressed it yet. So that's why I was interested in the bismuth, because if we can compress it, then it simply turns right into that other device. So, oh man, sorry, I forgot the name real quick. But basically, he had a big tube, right? And in that tube, he was able to put this in there. Now, you use a cold current tube. So you got 2 halves of a copper pole, right? But now you got on the outside of that the tubing. It's not right up against the wire. So it's the tubing itself that creates it, and then another one. And all you have to do is slightly trigger it with a little bit of heat. It turns all of its cold energy into hot energy, and it automatically runs a motor, for your car, and it'll make you go as fast as you want to go. And as soon as you let out the gas, it goes right back to cold energy.
Interesting.
Yeah,
That's fascinating.
The Edwin Gray.
Nice. God, there's just so much, right? It's like you just like every day you learn of like 10 new devices, and it's like they all have implications in the work that each of us are doing.
That one I'm working on, Bernie, they said it might be a time dilation device.
Yeah, well, Mike even said like when he built original M machine, like a monopole motor, that he's had some time dilation effects that he was noticing when running it, and just like it was basic one, right? So it's like seems to be a common theme when delving into this and breaking down energy and mass into the time space, and that time is a part of it.
Yeah. Well, what's crazy is most of these systems, they define them by the energy that you put into them. And I think it's completely the wrong way to go. You have to define it by the energy in the room. You see, they don't calculate in any equation. You know it's affecting it when it gets colder. As soon as that device starts getting colder, you pulled in the energy from the room. So that's one of the things. It's a temperature differential because you have to create the vacuum. So you have hot on the outside, cold on the inside. It has to flow in one direction. It's like going out on a winter day, right? And you basically take your hot house and you open the window, and everything pulls into that one like a vacuum, right? Well, now you're pulling the energy from the outside to the inside. Now you're creating a vacuum in one direction. You're pulling extra energy in. If you think of it that way, your room is pretty much how much energy you have. So what's over unity at that point? I mean, how much energy is in your room? Did you even calculate it, or did you just calculate the base system? You see, the base system was meant just to run as a primary mover. It was never meant to be what you're pulling out. You know what I mean? That's what people misunderstand. You're pulling the energy out of the room.
Exactly. And like even my electrolysis devices and units I created, it's like every time I plug them in, it just starts getting colder. And it's like, you know when it's operational and it's a part of it. And it's like, right there, evidence you're not breaking any laws of thermodynamics. It's an endothermic reaction, sucking energy from your environment, turning it into like plasma or electrics or whatever it is in the reactions, right?
Well, that's the whole key to a room temperature superconductor, isn't it? If you can pull the energy from the room, you have it. See, the thing is you got to be able to trap fields. You have to be able to trap a scalar field and a static field to another scalar field so that it bounces in there and stays.
That makes sense.
So when I tell you about my gravity fly, I tell you there's fields in it, and one field interferes with the other one and holds it in or it pushes it out. I'm telling you the same thing. I'm telling you, I got a scalar field, I got a static field, I got a scalar field, and I'm just building every single stage of it until I can get to a massive amount. So
I was going to also mention that bismuth and aluminum, both key elements in the aspect of the dielectric and the magnetic properties of winding, especially in coils. We need to start somehow get a metallurgist or something to make us these specific wires. And that when I first got into podcasting, it was Rick Lambert, former military research, but he gave me these coil blueprint designs that he said they were working on. He was like, the key is to have a 95% bismuth, 5% aluminum wire that you use to wind them, and that was where you will get the strongest fields of being able to get the right frequencies through them.
Well, that starts to make a lot more sense. Well, bismuth itself makes everything spike. Your energy goes right to the roof. If as long as you create the crystal form and not the lead form, you're going to start spiking immediately. That's why it's so important. You have to have fields that hold in fields in order to spike them in cavitation, in order to get that sucker to really start building energy inside of that little field right there, like this. You get what I'm saying? At each layer, it builds in, then it builds in. It's like capacitor after capacitor after capacitor, and it basically, depending on how fast your rotation is how much capacitance you'll have in this. That's why they say time dilation, because you're going to start taking the energy in the room, and you're going to fill this entire room with that energy, and then it's going to start pulling. So now your room is the whole device. That's the whole key to it.
Keshi actually, in his plasma coil designs and teachings, states exactly that as well. And it's like an energetic pressure that you're getting, flat and field pressures.
Yeah, the one problem is with this stuff is you can't create one without inherently creating all the rest. You know what I mean? As soon as you get to it and you understand it, you're going to create time dilation. You're going to create gravitational effects. They're the same thing. And if you don't realize that now, it's going to be a hard road to get there. It's literally you create one, you create the other, and you have to create both of them.
So then it begs the question of you don't want the super fast aging time aspect. You want the slowing down, going backwards time effect.
Have the right direction in mind, right? I already got enough gray hair. Maybe I'll go back to black or something.
Right? Yeah. Just come out a skeleton? No, don't want that.
They see me on the news as a skeleton. Still got the hair sticking out even longer.
Right? Just giant beard, big nails.
The first recorded instance of spontaneous skeletization.
Have y'all ever heard of Madman Markham? Surely. No?
I don't know.
No.
Oh, man.
I'd like to.
It was a dude that he was experimenting with super high voltage, and he claimed that with I think he was using pole pig transformers. He was basically making a Jacob's ladder using real current, like from the power line. So it was a lot, like 40,000 watts. I mean, it'd be about 40,000 watts off the pole. And he claimed that when he's shown a laser through it to help start the Jacob's ladder, when he threw something in there, it like there was a delay, like a second delay before it would fall, and it would disappear. And then this story goes on, and he claimed that he made a giant one. He ended up getting the millions of dollars from investors, and then he jumped in it, and he disappeared for like 2 years, and then he pops back up.
Yes.
And well, he claims that he you should watch the story. I think it was on Coast to Coast AM. Yeah, look at Madman Markham Coast to Coast AM.
Video on it recently.
Yeah.
Now that
Yeah.
The red-haired guy.
Yeah, I have kind of a feeling that maybe he got arrested, and that was the disappearing act. But because he had a warrant out. He did have a warrant out. I'm not a warrant, but he was on probation for 5 years, and it was convenient that he was on probation for 3 years. It's 5-year sentence, and right at the tail end, he disappears, and then he pops back up right at the end of that sentence. That was the only thing that got me on his story. But what was surprising is that he actually did have a lot of transformer knowledge, like real transformer knowledge, because he was trying to make ELF, which is extremely low frequency, and you got to have some big capacitors to do that. You got to have some power factor correcting caps. That's really the only way you can do it. You got to stack them, and it would be like a whole closet full to get that kind of low frequency. So he knew all that at 20 years old. So he knew, he had some knowledge, but I don't know if he actually was a time traveler. I think he was a jail traveler, but
jail traveler.
Yeah, and it was perfect because all the investors, you know, they didn't know if it was real or not. You know, it was actually the perfect storm for him because he ended up getting a few million out of the deal. So who won? You know.
Yeah, I guess.
I mean, if he outsmarted the public enough with a stunt to make $3 million, I mean, damn. You know what I mean?
Yeah, I guess, man.
That's I mean, I wouldn't want to do that, but I don't think he meant to do that either. I don't think he planned it out, but I think that if that's true, then it kind of fell into his lap. Those opportunities fell into his lap, kind of thing. Because when I had thought about it, I was like, that sounds like that's what kind of played out. Like he got in trouble for something else, and it violated his parole.
It kind of tells you if his machine worked, because if it did and you got $2 million, let me tell you this right now, I'm turning on that machine and going back in time. That 2 million just became a lot more. You know what I mean?
Right. Well, no. So I don't know if you listened to what he said about it, but he said what it was like was he created the field and he jumped in and he was instantaneously 2 years in the future. He said he lost his memory for a couple hours and he didn't know where the hell he was at. And then when he got around, his shop had already been like taken over and it was 2 years later. That's what his claim was, which sounds like what would actually happen if you could manage to pull it off. But so I don't know. And I know he knew about how you could pre-ignite the air by using a laser to pre-ignite the air for Jacob's ladder. He knew about that. That's accurate. A lot of the key details about what he was doing was extremely accurate. So that's what kind of confused me, to be honest, was he was right about a lot of the key electrical engineering things. It's just the story of jumping through time that I don't know about.
Thing to investigate further is to see if there's a jail record of him over those 2 years or incarceration record, or if nothing at all.
Yeah.
Right?
Well, I know some states are hard to get it. Like the state I live in Texas, you have to pay. It's kind of hard to get that record.
Oh, it always costs money. Yeah, that's the one.
Yeah.
thing.
Now in Oklahoma, it's open source. Everyone can look. So some states are, some aren't. I don't know how many people, maybe his investors would. They'd investigate probably. I don't know how they didn't get exposed. He didn't get exposed if that, you know.
Then you'd have to go through there with gold because
and he could have had it expunged. He could have had it expunged and sealed.
Yeah.
Then you'd never know. You'd have to have a court order and a reason to know. So
it's like who goes to jail and comes out with $2 million?
Well, no, he had 2 million already. That's the thing. So he started out small, got the investors, got a big shop, got big transformers, got real equipment, made a big field, and then he disappeared after he had already got the money. See, he already had the money. He already got the money.
Maybe the government just let him out and let him
Well,
go.
if he had
information.
I mean, imagine if a guy had $1 million cash in a shoebox and then you go to jail for 2 years and get out, and if you can find your money, I mean, you're better off than most of the people in the world. 90% Americans getting out of jail.
Sounds like more like the government funded him, got him to do the research, put him in jail to make
Someone
sure
did.
they knew
There was
boss, and then told him to get out.
Yeah.
That's what it sounds like.
Yeah.
They do that kind of shady stuff.
Yeah. And that is easy. It's real easy to do. All you have to have is a crooked investor that's connected to the government. That's it. That's all you need. And one investor can actually steer somebody in a psychological way a little bit. Oh, yeah. Of course it happens.
Oh, yeah.
A lot of that being exposed in the U.S. AIDS scandal currently.
Oh, yeah.
Oh, man. I'm like I better not say, but as far as the corruption and stuff, I'm like a pig in mud, man. I'm loving it, watching the news, seeing all that exposed, because we all kind of knew it.
And we know who's
all
mad
along.
about it too. That's what's even funnier.
Yeah, I mean, I don't care about them getting mad about it. I just care about the fraud, man. And they don't want to talk about it. That's crazy. They don't want to talk about it. It's like it doesn't. They're not even hearing it. Huh. All I hear is he Nazi, Nazi. It's like, where's your argument though? Like, what's your argument? That's my thing. Like, you just give me an argument of why USAID should keep going with all the stuff we've already uncovered.
Yeah, it shouldn't, and it won't. It won't stay there. They're getting rid of that.
Yeah, they don't want to answer those questions, and that's the first question I have. So it's strange that they don't even think about it, but whatever.
That's not strange. They're protecting their butts and their money.
You're talking about the politicians themselves. Yes,
Yeah.
absolutely. They got skin in the game. You bet your ass. That's
having
worse
an
than death.
unelected official do the dirty deeds of the executive branch is the successful unification of corporate and state power, which is what Benito Mussolini described as
Definition of
modern-day
fascism.
fascism. Yes.
Yep. Yeah, I mean, it's pretty rough, man. There was a lot of corruption. Like, politicians shouldn't be worth $100 million. Like, that's kind of weird. It's like they allowed insider trading. They allowed a lot of stuff. Yeah.
Yeah, they did.
Well, corruption's in everybody. It's in all of us.
Like husbands and hers, like trades. It's like, oh, watch what they sell. Oh, the legislation comes out the next day every time.
That's right. So funny.
Yeah.
All right, back on track. More about your MEGs, because that's a fascinating subject. And so it stands for
Motionless magnetic generator.
Magnetic generator. Okay, see, and I had always thought that they were ones with motion in my mind for some reason. And is there another one that's very similar? That was like the magnet generator or MG magnet generator. Like, I don't know.
There's like a dozen ways you can skin the same cat. You can make them in motion. You just got to balance it right and have everything else right. You got to think about efficiency. Imagine anything you can do to make something more efficient is in the right direction already. Because if you're not extremely efficient with whatever device you have, you'll never make it over Unity. And I want to say one thing real quick. To put it in perspective, every one of you have had an over Unity machine in your house the whole time. Every one of you.
In your microwave.
Well, maybe, but the main thing is your air conditioner is a COP of 4 to 5 right off the bat.
That's true.
It uses material effect, and the atmosphere is a sinking source, which is free energy. If you can, because tell me, how is that you can extract energy for less than the energy you're receiving? How does that? It actually doesn't violate thermal the way they set it up, because they had to give it a exclusion. They had no choice. So it doesn't violate thermal, but it kind of does. But anyway, it's kind of a cluster F. But yes, you can actually do some amazing things if you can reconvert your heat pump back into from thermal to electrical energy and close the loop.
Yes,
Sure.
You would be extremely surprised what that's capable of. Because there might be
guy that was doing something like that. I remember, like in the 90s, I believe, and like they kept throwing him in jail and trying to like charge him with fraud and stuff. If I'm
Yeah, well, now imagine how efficient it could be, because now you got scroll compressors with inverter systems that are way more efficient. So it's like 900 watts puts out 13,000 BTU hours. That's a COP of almost 5.
Yeah,
it is. I think it's 4.9. So right there, if you have a Peltier, it doesn't even have to be a very efficient Peltier, because you have a COP of 5 to deal with. So imagine what you could do if you just made a sink, basically a heat, want to get hot, put a Peltier on it. Now what do you have? I don't know. It's probably going to be close to looping already, depending on how efficient of a Peltier you can find, which good luck, but you can make them too. If you do some research, you can layer your own stuff. But yeah. So, but there's other ways to do it. You can even make hot water heaters out of them so that you have a really, really efficient hot water tank. or maybe if you could cook with it. I don't know. I don't know if you can get it that hot, but you could definitely get maybe 130, 140.
Wait, air conditioner motors basically a brushless DC motor that they put AC in and then convert it back to DC. So you can even improve that part of it. It's real simple.
Well, a lot of the older ones are basically AC induction motors, and now the newer ones, yeah, there's brushless DC, which is an inverter, or you can stick to the regular old compressor that's got it's basically a motor. It's just a regular AC induction motor in there. They're not that efficient, but the newer models, the scroll compressors are actually pretty good. You go inverter, you can get up there pretty high on efficiency. And the DC air conditioners I'm putting in my RV for the off-grid RV are DC scroll compressors at 24 volts. So they're already even more efficient because they don't need to reconvert to DC. It's already DC straight off the battery. So you're going to get the highest SEER rating right there. And R134A is actually a little bit more efficient than R22. So that car refrigerant's actually pretty good stuff. It's just not certified for use in homes. That's the only reason it's not used. In a house, yeah. But you can use it. Oh yeah. You can even use propane as a refrigerant.
Oh yeah.
You had to. Yep. You can use
I've seen
propane.
that firsthand. That's like it's cold.
You can even use certain types, I believe, keyboard air duster. There's a couple of things, believe it or not, like I think there's a certain fuel you can use. There's a couple things you can use as a refrigerant that most people didn't even know.
All right, guys, real quick before we go any further, I just want to let everybody know we offer the memberships on the channel. And right now, Ben and I are going to throw some in on the game and give some out. Just so you know, up in the upper right-hand corner of the chat, there's 3 little dots. Click on that, and then allow yourself open to get gifts on your channel. And you can accept some of these memberships that go on for a short time here on the channel. And you can get in and be a member. It'll throw them out randomly. So
Absolutely.
I'm going to
cool
throw
deal.
in, yeah.
So we'll give everybody a second to toggle their setting, and then we're gonna throw out. I'm gonna throw out 5 free on my channel, and then Nathan, I think you'll throw out 5 free on his channel.
Yep, there it is right there. 5 memberships, man, right there. And then I also wanted to take the time right now to thank Gino for subscribing earlier. I really do appreciate that.
Yes, thank you, Gino. That was awesome.
Yeah,
And
cool.
we got Ben's up there. So, all right. Sorry, guys. I just wanted to make sure I got that in. So
Nice. That's really nice of you to do that. Yeah, that's really cool. You're one of the first YouTubers I think I've seen do this.
well,
To be honest,
you know what?
I don't watch a whole lot of lives, but yeah, for me anyway.
I got some pretty cool stuff back there in the membership stuff. I have basically Linderman's book, and I put it on a AI voice. So you just have to sit back and listen to it as you're doing some work in your shop or your garage or whatever. Dude, he talks about cold energy and stuff.
That's
really
cool.
awesome stuff, man. And
That's cool.
Byfield Brown effect is on there. Also, the Coils generator is on there. There's a PDF of that. I went ahead and did that as well. So yeah, it's some pretty cool stuff on there, man. I go in there throughout the time, and whatever experiment I'm working on, I do a lot of live updates and stuff on there. So
I just wanted to take a moment and welcome new members: Jessica C., Aaron Corbett, Harry Kevlar, Chris Hayes, and Tom.
well on.
Nice. Hey, I got a question for Ben. I see you got the Great Pyramids behind you. Did you happen to watch my pyramid theory?
I did not. Send it to
Yeah.
me. Send me a link.
Well,
Send it to me,
I
bro.
can't right now because I'm on a phone, but I can.
Or yeah, email me. Yeah, email me the link
On
to the
YouTube,
video.
it's on my channel. It's right there. If you go to videos, it was one of the recent ones, I think.
Give me a second. I saw it earlier.
Yeah, I mean, you can play it if you want. But you know, it was a theory about them pumping tritium into a spaceship that sat on top of it. That's what I think. That's what I think it is. What it is. personally. It's just one of my theories. I mean, it could actually be a few things, but that's one of them. Yeah, you can play it. Yeah, go ahead.
Well, let's give
Oh,
it
there
a
we
shot,
go.
man.
Yeah, let's check it out.
So just to put it simply, this is the subterranean chamber, king, queen, gallery. I didn't list that. Some more ports. I think this was a spaceship recharger, and I think it was ours. I think this was our technology a long time ago. I know some people have feelings about that, think, whatever, or somebody else said that a long time ago, and I'm like, show me the diagram. Show me everything. Show me the diagram where they're talking about tritium and hydrogen-3 being pumped into it like this, using groundwater to convert it into hydrogen-3. Show me that. Show me where someone has come up with that, because that's cool if they have. I didn't look for this. This came to me kind of when I was just meditating about it, and I kind of had a hunch that that's what it was, but I didn't go into full thought on some details until recently, and I was like, yeah, that's probably definitely what it was. And I think it was us, man. I mean, that's all it was. I mean, it wasn't another race. It was us. We're just a little different now. That's my best guess. So yeah, and there's some of that. But yeah, I think it's just a lost technology. I think we've had this for a long time. And I don't think we look that much different either. Because yeah, the pyramids, everyone's, oh, you're only 4,000 years old. Yeah, right. You don't have any idea. You know what I mean? You can't even explain how it was built. Don't tell me that with a copper saw. Let's see you cut a rock. Let's show me exactly how they did it. I will even let you use modern equipment. Let's still see you do it. A small scaled model. How come no one's done that? Huh. Interesting. Anyway, yeah, guys, I think I think there was a ship that sat on top. Most of y'all in your subconscious probably thought about this kind of. You just maybe not think about this. Now, the tritium is, I believe, a base material. I think they can use it for a lot of things. But yeah, that's what I think it was. Obviously, humans scavenged it after they woke back up, and then, some events happened, and then they kind of came out of the cave and was like, hey, we could use that for a roof, I guess. I don't even remember what it was for, but that's what happened, in my opinion. This is a theory, by the way. I'm not saying this is fact by any means. This is just my thoughts and opinions, and I know Tim has kind of felt the same way. So, Gary, we've all talked about it for a long time. So, yeah, if you think you come up with it I don't care. That's fine. That's fine. This is free anyway. I'm not making money on this, so it doesn't make any difference. Anyway, yep. And I'm actually a little nervous about this one because it might trigger some people. So, but whatever. I mean, it is what it is. We can speculate all day. I have the First Amendment right to do so. So, and also, it's crazy. This country's into chaos. It looks like something's trying to rip it apart from the inside out, been infiltrated. So if any, I know certain entities are watching me. You ever need something, you just give me a call, man. I can make you some incredible stuff.
Yeah, yeah, you can pause it. Yeah. I'm sorry. I was going to cut in, but I was like, well, he'll probably do it.
It's interesting. So you think we're recharging the ships for like spaceships to just land on
possibly them? Because the main thing that made me think that, and I don't know exactly, because we took the cover off, right? The humans took it and used it as a roof. So, but what it looks like, those ports, those or they call them air ducts, but what I think that was a check valve. It looks like a check valve because there's even a door up there. I imagine like maybe the ship had a probe or something that could stick in there somehow from the outside and poke that block through, and it would release the pressure built up, because there was evidence of a chemical reaction. There was evidence of an overpressure event inside there. So it looked to me like a chemical factory, like it was basically in some way either adding energy to hydrogen through the magnetic field of Earth or through some other natural means and creating hydrogen-3 to pump in there. That's what I think. Yeah.
Interesting. So I know it creates hydrogen, that's for sure. You didn't need chemicals to be put down it.
No, because you already got groundwater. So all you have to do is a little chemical reaction, which some people may think is impossible. You can't do that. Well, there's a lot of things that are supposed to be impossible that's been on the news for 6 months now. So I don't know we can make a list or something, but there's
Well,
quite a few things.
All you have to do is resonate the chamber. The resonance itself brings
Yep.
in the electricity. So you take the
Right, like,
groundwater
that's
that pumps
a
in.
hydrogen generator, like for sure.
Yeah.
Yeah.
I mean, imagine. I bet it's so simple, it's stupid. I bet it's so simple, it would make you feel like you're drooling on yourself once you actually see how it worked. I bet it would be like, dang, I feel like a monkey now. I mean, dang, man.
Well, what it is if you take resonance, just like I do in the Tesla coils, and I put the primary mover right here, and then I put one next to it, it'll shoot out plasma in a vortex. It goes as a bipolar Tesla coil with a null zone in the center, and it'll shoot plasma all day. All you had to do is hit the right resonance point, and the chamber itself is set up where it goes like this. Then it goes smaller and smaller and smaller. Each one of those, if you calculate the distance between them, you're in either the scale of A, B, C, or D in different octaves. And that's all you have to do is create the resonance inside there, and it creates a plasma.
Yes.
And the water in the bottom was pumping up, so it takes it and it makes a water hammer effect. As soon as you get that, it sends out a pulse wave and boom, right through the whole thing. So you're literally shooting it up. But in that as well, because the granite itself will suck in water like a candle wick, the entire thing will eventually be covered in water. So it'll feel like it's under the ocean is what it'll feel like when you're in there. But that's exactly the effect that you want. And that in itself will split it to the hydrogen and oxygen. You know what I mean? That's the chemical process they're doing. So it's not anything unlike the what was that one we just looked at with Bob? The whatever generator, thunderstorm generator. It's all resonance in order to create the plasma.
Yep. Yeah. That's what I was actually, when you were talking, I was thinking the thunderstorm, but I didn't want to cut you off. But yeah, because I'm bad about that sometimes. So sorry in advance. But yeah, thunderstorm generator does exactly what you described. Precisely. And isn't it interesting when you look at the King's Chamber, the way they did the roof in that room? Think about it.
Yeah, it's one.
I mean, no, I'm sorry. The galley, right? Because it tapers up. Yes,
it's exactly
that's what I mean. Yes, that one.
Grand Gallery. Yeah.
Yes, it looks like they were going for a conical echo effect, just like the thunderstorms Venturi that he made for the thunderstorm.
There's a few of those throughout the ancient world. There's more in Crimea and a couple other pyramids. I've also seen it on Mexico's coast, in one of the pyramids there too.
Yeah, man. Yeah, we were global then too, and something just tore us up, man. Something came here and just knocked us out. Maybe it was natural, maybe it wasn't. I don't know. We can speculate, and I don't even know really when it happened, but I know that it was at least 12,000 years ago. But it may have been actually later than that it happened. I'm not sure, but that's what it looks like. Or actually, no, it could have been more recent because the Egyptians had cocaine in their systems, and it shouldn't have been there unless the climate was different. And it could have been the climate was entirely different then, and it could grow there. But that grows in, I think, South Africa, or wherever. It's a different continent, so it's like, how did they get it?
I had no.
You know what I mean?
They had cocaine in their system, really?
Yes, they had trace amounts in the mummies.
They tried to claim that it was the Europeans that just spilt it and wasted it all on the mummies.
Yeah, no, the Egyptians knew how to party, man. They knew how to party.
The cocaine.
No,
party.
have you seen some of their pictures? Some of their pictures, I won't describe them, but some of their pictures they left is dang, if you went to Pornhub and took a picture, and then you made it a sculpture, that's kind of what they did.
Oh man.
Do you know what I'm talking about? Do you know the picture I'm talking about?
No,
there's a girl drinking beer while something's happening behind her. It's like, holy cow. The Egyptians, they were like party time, buddy.
Oh yeah. I had a feeling they were all about partying.
Yeah, would we do that today? Would we make a sculpture of that today? No. That's kind of weird.
Some of them, yeah.
Man.
I think there might be some of those, in Hollywood.
Yeah, it might come out of the. Yeah, if it was normalized, I think it would be normal to us too. We wouldn't think anything about it.
We'd just like that on the streets of Paris today.
Yeah, there could be. Yeah. Imagine if it was everywhere. Like that would be weird, wouldn't it?
Thank God the Trump pendulum.
Yeah, thank God it's. Oh God, don't. No, I don't want to think about those statues.
Well, I think you guys it may have just been that they turned the pyramid off was the problem. If you're using a frequency device in there and you pull it, then guess what? You just changed the world and you just changed the gravity in the world. So the oceans are going to start letting loose the water that's underneath inside the rock, and we're going to flood, buddy. That's exactly what would happen.
So they only charged up once and then they flooded everything.
No. They probably had it on for millennia.
And then when they shut it off is when it all. Oh, I see.
You pull the ark, and guess what? You have all hell to pay.
Wow.
Well, do you know that the Nile River ran right beside it?
Telekinesis, potentially, like a collective consciousness or something. Who knows, right? Like it could have been some sort of higher technology or like aspects to it. And then once the grid went down, everyone lost that one world or language potentially.
Yeah.
Like Gerald says, it probably wiped everybody's mind, and we all went back to the Stone Age.
Man, there would be a lot of people that would struggle if the internet didn't work. There would be a lot of people that would like struggle to survive. You know what I mean? Yeah.
They'd be going through withdrawal of.
Well, if it lasted too long, it would be pretty bad. Yeah. Yeah.
My power was recently out with those fires, man. It was the same thing. Yeah, I was going through it. Couldn't get online. Couldn't do any work. Couldn't do anything. Just yeah.
You're starting to feel a bit.
Well, now imagine a world. Imagine a world where like the solar flare takes us out, and it's like a 6 to 9 month delay to fix it.
I would build my own generator before that. Hey, wait 9 months.
It probably could happen faster. Like I think they could probably fix it much faster if we had to. Like I think it could probably be 2 months, maybe 3 months at most. They could probably actually get it back up.
Yeah,
we're talking about the government here. They don't do anything fast.
Well, you put people in a desperate situation where no one's got power. The humans will come together pretty quick on at least one thing. You know what I mean? Eventually, once they realize we're in trouble, yeah. You'll be surprised.
I'm an optimist.
I hope so, because 9 months would suck, man.
I know it would. We'd be sweating after a couple of weeks.
Oh yeah. I might actually have to go out and do some yard work. That's gonna suck. Yeah, forget that. I'm just gonna hire somebody.
Gonna have to cut the grass with a machete or some other apparatus.
Get an old school sickle.
Life's gonna be different. You're gonna be like Flintstones out there with the one of them things. You know what I mean? Them blade things.
You put a device on the dog.
Yeah, there you go. Make a sled, a dog sled with a mower on it. Yes.
The dog's eating the
grass.
one
video of the dog driving the lawnmower tractor thing.
You guys know a tractor in the 1700s was a mule.
Yeah.
All you had to do is strap it to the back of a mule and then gear a wheel off the ground where it speeds up, and there you use your mower.
I think they're still used in like 3/4 of the world today.
Yeah.
Right?
Yeah. That's all you got to do is get a mule.
Yeah.
And yeah.
Right. They don't have TV over there, I guess.
Yeah. What's terrifying about that kind of scenario is that what you have is what you have when that event happens, pretty much.
Yeah.
What you have is what you have is what you can at least expect to have. So
at least
something to think about.
At least I know I have lighting for a very long time. And that's what I got.
What kind of lighting? What kind of lighting do you have?
Oh, I'm using a modified Jewel Thief with my system.
Okay. Hey, y'all want to know another real easy way to get free lighting that requires no tricks, no nothing. Yes, basically, once you buy the stuff. So you take, this is Hector's thing. He's been doing it for years. You can run LEDs without a driver. You don't have to have a driver if you wire them right. If you wire 4 LEDs, I believe it was either, I think they were 4, it could be 4 regular LEDs in series, or it was 4 12-volt. I can't remember. But you want to add a 12-volt solar panel to it. I think it was 4 in series to a 12-volt solar panel, with no driver, nothing between them. Just wire it together in series, and then put the panel out. And if you get it right, if the LEDs or the voltage is right, you don't even need a resistor if you do this, because the voltage drop across the diode is enough to regulate it. So what happens is you have a incredibly efficient light, because the LED doesn't have a driver. It's straight off the panel, and you've sized the panel right. You put the panel outside, run your wires in, and now you have essentially a light. Every time, the moment the sun even barely hits that panel, you're going to have light coming on, because the LED is wide open to the panel. So, and it works. Like, he's got a light. He's got a big one, because I think he's got a 50 or 100 watt panel outside on the roof and a giant 4-foot LED light running with it. He wired it the right way. And then it's been like years, and it comes on every day. So if you had like a barn or a garage, you could do that and have light for years for free. It's the moment the sun hits it at all. Because remember, LED is super efficient, right?
But we need lights at night is the one issue.
Yeah, that's where the other one comes in. But I'm talking about, like, if you need a powerful light.
Really, set up.
That's like the joke of the solar-powered flashlight.
Yeah, well, if you had, like, imagine if you had a deep barn or a deep shop and you needed light in there and you didn't have any other source. That would be a great,
a barn or something,
powerful light. No, it's extremely bright. Like, it'll be full brightness, whatever bulb you use with the right panel. So you can have like essentially 100-watt light on in an area where you need light, like inside a building, for free.
Store it in a battery, for.
You don't need it. You can, but you don't even need a battery unless you want. At night you could easily switch over. But the idea is that you don't need any chips. You don't need nothing. Just a panel and LEDs. That's it. And you can make it work. And I promise you, in third world countries, that would help them a lot, man, in their factories, because that's where you need it. And it's free.
Simplest design. Yeah, you need the simplest.
Yes. And it'll last a long time. They won't overheat as long as you match the voltage drop right. You just got to hook some up. They're cheap. So hook some up with a panel you might have laying around and see if it works. Yep. And if you get it to where it's about at maximum brightness, it'll last a long time, as long as the LED lasts.
I've been meaning to test with some solar panels, but the problem is last time I had like a little solar panel light that I, tried to set up on my porch area. Some kid, some dick, like walked by and like stomped it and like crushed it. I'm like, okay, so I can't set up nothing.
Can you get like a pole and set it in your yard where it's high?
Well, what I can do is just monitor it, like I'll put it out there, but I won't like put it out there when I'm not home,
I see. Yeah. Yeah. I mean, yeah, you can do essentially a eternal LED light too. I just for a super bright one, I guess you could if you had some big enough stuff going on, Yeah. You could make a pretty good one.
Interesting.
Yeah.
Things you could do with all this stuff, huh?
Well, Akula had, I think, a 60-watt version, but he changed the schematic a little bit, so it's harder to reverse engineer. But it gets you really close. His big schematic, I've got it. I think it's still on the internet. It's like a 60-watt or a 40-watt. I can't remember. Yeah, it's there. It's a pretty complicated device, but.
Yeah, that breaks my rule, man. I don't go over 10 components on this stuff. No, thank you. Yeah, you gotta make it work so everybody understands it. That way. Yep.
You know what I mean? I like it to fit on a napkin.
Yeah.
If it fits on a napkin, it's probably okay.
That's right.
Yeah.
It's got more than 10 components. I bought it off the shelf. That's the way it works.
Yeah. No, you can do a lot with a lot less than that. one of the most efficient ways I've ever seen that you can drive even any type of motor, like a brush, especially a brushless, like a BLDC motor, is with a Bedini switching circuit. It's the most efficient way I've ever seen something that could drive something like that.
Yeah.
It beats any driver. Yeah, it'll beat any driver, like any BLDC speed controller. It'll beat that if you get it set right in efficiency.
That's
Yep.
interesting. I'll have to try that. You say the
Because all it is a
switching circuit.
transistor and a resistor and a signal. You got to have a signal coil. So you do have to sacrifice either a pole or you got to do some other trickery, but you want to use a coil trigger. That seems to be the easiest method to make a trigger.
Well, don't
So
you
you
have
need
to have
little piece
three
copper.
pulses? You have to have three pulses, right?
Yes. So
Because-
if it's a 3-phase, you would do 3 separate Bedini circuits.
Yeah, because all
Independently-
BLDCs are 3-phase.
Do what now?
Brushless DCs are 3-phase.
Yeah, you can do
Okay.
3 independent Bedini circuits. You take phase 1 Bedini, phase 2 Bedini, phase 3 Bedini. It's just 3 transistors. You just give each phase their own, so they're firing synchronized because you're using your coil as the trigger, so it's already timed. Now, if you want to advance or retard the timing, you got to do something different. But yeah, you got to sacrifice. Like if you have a 36 pole BLDC, I'll run it with 33 instead of 36. 3 I'll sacrifice and use as triggers.
Gotcha.
Yeah. And you can adjust the wind so it doesn't drag it down too much, because you're just trying to get a signal. So you do have to have an induction, but you just use the right resistor, like a 60 ohm, 50 ohm, something like that.
That's so cool,
Yep.
man. We're all hacking things.
Yeah, well, Bedini had it going on, man, and that was a real simple. Man,
Yeah,
I
he
think it's
knew
3
what was up.
components. Yeah, I think that's 3 components. The Bedini circuit's 3 components per leg for a 3-phase. But if you can run a lot of motors with a Bedini. You can run a single phase motor with a Bedini, especially if it's permanent magnet. You can still turn that too. Yeah, you can turn almost anything with a Bedini circuit. Yep. It's no different than the jewel ringer. If you have a self-oscillating jewel ringer, you're doing basically the same thing. You're using itself as your timing control.
Exactly.
And in that case, you're using its resonant frequency as your timing control, but because it's just bouncing, you know what I mean? It's bouncing back and forth.
Right.
Like the Russian ringer, it does. It's self-resonating. So, yep.
Yeah, it's funny when you put these things in resonance, they start to create their own energy, man. That's what's really cool. That's why I show that on my channel so that you can see that they're producing energy. It's not just that they're producing light for light bulbs. You know what I mean? You're producing plasma from them. So they're, tie it back in with a capacitor or a 3-way spark gap and draw it right out without interfering with the resonance frequency of it. And you're good to go, man. You capture all you want.
Yep. What I usually see, what at least all the greats that I've talked to have told me is that in any coil collapse, you could potentially collect up to about 1.6 of what you can put in, because the coil collapse will collapse back and spring at the golden ratio. Now that's complicated. It sounds, when you think about it, it's like, oh, that's probably complicated. I don't even know what that means, but it's actually pretty simple too. That's just what the back stuff is.
And I can explain it very simply too with the recent breakthrough we've had just by using a diode in the correct placement. You can capture some of that back EMF more, and it doubled the brightness of my 40-watt panel. It was only about 1%, but it doubled it from what it was, meaning like we're clearly wasting a lot of that. We're not seeing all of it.
You can get up to about 1.6. Now that's difficult, but you can get 1.1, 1.2 with capacitors and stuff that we can do. You could do it yourself if you tweaked enough stuff. You would run into a condition eventually. Yeah, it takes time. Like it took Tim years to get
Yeah.
his machine set up in a condition, and that's swapping parts, trying different things, changing the coils, changing the wiring, changing everything,
Exactly.
every variable. Yes, every
Yeah, it
variable
takes
has
a
got
long
to be
time to
modified.
tune your system.
Yeah, you're essentially
Face our
doing what
own
nature
challenges.
does. Nature goes about things by trying every possible way until something works, and that's what you got to do.
Yeah.
Yeah,
No, I agree.
that's
That's kind of like my process. And when we do our interactive mini labs, you'll see me sit there and kind of like try this or try that, or
Yep.
like, and have different people suggest different things, and we'll try them out together and just experiment.
Yep, that's what you got to do. That, and I love it, man. I get excited when I do it.
It's
So
fun.
yes, yeah, I've always loved it, man. It's very fun
Yeah,
experimenting
because
with
you
stuff.
always have those unexpected moments. Like I remember a recent live stream, we got like our pickup, like just free pickup energy from our pickup coil. We got over 200 volts coming out of it. I don't remember exactly how I did. I have to rewind the footage and go over it, but we got 200 volts coming out of it, and I'm like, what
Yeah,
the heck? And it's not affecting the main system at all.
yeah. So there's a lot of anomalies like that you can run into, and initially you might think it's a problem with your meter, and sometimes it is, but you got to check
Yeah,
it. But if you
sometimes
check it
it's
with
not the
multiple
meters.
meters,
Yeah.
yeah, if you
Sometimes the
check it with
meter
multiple meters, and it's the same. Yeah,
exactly. Yeah, but that's why I want to try to go over and verify if it wasn't like the meter bumped up against something, because sometimes that happens.
yep, yeah, you can get some weird fluctuations sometimes, but if you have the condition on multiple devices and multiple machines and multiple meters, then that you can rest assured there is something going on. Now, what it is, you may not know, and some of the stuff we ran into, modern science can't even answer. I've got scope shots of ringing events that are occurring long after the pulse, and they're increasing in intensity. So, and I've got them. I can upload them somewhere. I'll have to dig for them. They might be on a drive, but yeah, I've got
Yeah,
the
that's
scope shots.
crazy.
They
Was
might
that
be.
in low
I
hertz?
can't remember. I think, huh?
Was it in low hertz?
No, I don't think it was low. It was, I think it was from above Unity or over Unity.com. So one of them has in their archive, they have the scope shots where they're showing the ringing event where it's like an amplification of some kind that occurs. And you can get that condition in many different ways, but they're getting it with partnered output coils. That's one way to get it. And they're getting it. And everyone basically on the website's getting it. Once they learn it, it takes a few months to figure it out. Some people longer than that, but once you figure out what's going on, it's like, oh, that's kind of simple. You're just bucking itself. You're creating something asymmetrical, and nature's having to straighten it out. When it straightens it out, it gives you a little more to straighten it out.
That's
Well,
exactly right.
Hold on.
Yep.
Every ring is not the same, by the way. So you
No.
can get a ring that only goes up to the 5th octave. So as you ring it, it goes back and forth, right? You're only adding the original number to the next number, right? So it would be the first number plus the second number, and then it would go back to the first number, add that to it. So that's how it works in the musical scale. So now you're going through your ring, and you're getting the first, the second, third, fourth. When you get to the 8th octave, if you can get there, you've blown over Unity right through the door.
Yeah, because it'll spike again, and that's what we see. I don't know if that's exactly what's happening, but I know that that's kind of what it looks like on the scope. It really is. That's kind of what it looks like. It's not as big as the pulse, but it's much bigger than the ringing event that is just a few nanoseconds behind it. And then there's this, it's almost like a second pulse introduced that is free. And you don't know where it comes from. Who knows? I don't see where it comes from, but it's there. It's coming in. And it's also creating its own ringing event. And it is a little different frequency. It looks a little stretched out, if I remember right. It's it's close. I think it is. I think you're right. I think it's around the 8th octave, but because it looks similar, it's kind of similar to the original pulse if it was in a natural ring. So yeah, it's hard to say, but yeah, that's what they're collecting off of. Is that it's nature trying to straighten out the mess that you made, essentially, because it always will. It always will, and it'll do it for free, and it'll do it at the speed of light. Yeah. It'll do it at near the speed of light. So
That's
So
why it's
basically,
interesting to
instantly.
play with these to dial things in, man. You think you're just there
Yep.
when you're getting plasma. You're not, man. You got a whole nother level to go.
Yep. Yep.
Yeah, that's cool, man.
Oh, so I actually promised that I would be on for 2 hours. I can go a little bit over. So if you all got any more questions or anything else you wanted to add to the show while I'm here.
Well, yeah, I mean, people are just kind of interested in that MEG, man. So if you can just give us a quick synopsis before you take off on that thing and kind of what your opinion is on it.
So you can do it high speed with the MEG glass. You can do it with any core that you want, really. But you're going to have to stay within its specifications of the core. So, and you can do that because whatever coil you make, you can stay within their tolerances with a capacitor because you can set the resonant frequency. And there's some more tricks to that on the coil type and the wire size and all that. You'll just have to look into some of that, but it's all there, and you can set something up like that. Big, small, it doesn't matter. Tim does a lot of low speed. He likes to do 60 hertz up to about 400 in some cases with iron. That's on transformer iron, like microwave transformer. We hack those up all the time, or anything like 3-phase, like industrial transformers. We'll cut those up, make MEGs out of those, because you can get some big ones like out of battery chargers and stuff, old battery chargers. You get that transformer core and you take the coils off, you can make your own. And we use stuff like that. Now, and Tim's got a self-running condition a few times. And I don't know how much detail I can go into. There is one that he had that we used a board that Captain made. So it did have some switching and stuff going on. Like it was a little more complicated than a Bedini or something like this. And he got it to loop for, I think, 50 seconds. And he had to adjust the amount of saturation like I was talking about all along. But once he got the sweet spot of saturation, he had a ringing event that kept it going for almost 50 seconds. And he had another one that was small that did the same thing. It was with a little ferrite. So you can do it. And we don't know why it stops at 50 seconds, but I'm pretty sure on both of them, you can put a load on it while it's doing that. And it'll still continue to run for about that time. So it's weird. It's kind of a weird situation. So you can do it with any material. All you're doing is switching flux a little bit. When you're adding a permanent magnet, you're adding a permanent flux that is able to move a little bit. If you move it too much, you'll demagnetize your magnet. So you got to be careful. And you don't have to move it very much. You can just move it a little bit and it'll generate a little bit. And if it's small, you can think milliwatts. You're probably not going to get a few watts out of a ferrite ring, but you get a transformer iron. Now you might be 10 watts or less, maybe if you get the condition and you get it going. You treat it like a RF network if you're doing high frequency, especially if you're doing high power, high frequency. You got to treat it like a RF network. Transformers are your friend. You can run them in series and parallel in systems. If you want to collect, like say, if you wanted to collect some reactive power off one of your your Tesla coils, you can. You don't want to hook it up directly to it. I mean, you can in some cases, but it depends on your transformer you build. You can hook it up in series to another load, like another loop back to itself. You can use a bunch of different high voltage systems to do that, and you can actually vector reactive power that way, as long as it's resonating through the transformer too. And then you can even add a second stage onto that transformer in series or parallel and resonate that too, and treat it like an RF network, like you're trying to run a radio station. Treat it like that. So you got to basically look at it that way, and then you're going to see some stuff happen. Let's say that you're going to have stuff in your hands that's like, that's interesting, because I'm not really you are causing a reaction to the system, but it's not the same reaction that everyone says and screams always happens, which is you destroy the resonant state, reactance, it all breaks down, and then you're way under unity because you closed the circuit and you added inductions, you added something, you added a load, so now you change the condition, now it's dead. But if you don't change you change the condition as little as possible, then you can collect off of it. That's one of the secrets right there. Now you may not get much. You're just going to collect off the spiral we talked about, the 1.618 golden ratio spiral. So you got to build a pretty big system to collect anything off of it. So it's going to take some pretty bulky stuff, but you can do it. Hector's done it. It's all over his website. Well, that is in EV Gray, but yeah, all his diagrams are there. They're open source, so you guys can check it out. All your viewers can check it out if you want. But that's one way to do it. But if you want the MEG, you're just going to have to keep the core under saturation, get the right magnet. Don't use a Neo. If you're going to do it like Tom did it. Use the same core, like the tape core. If you want to use that core is not quite the best in my opinion, and Tim's opinion, because of the layering. It's like a duct tape roll, the iron. So the flux does not penetrate the way you think it does because it's layered like that. So a lot of the flux tapers off. You're only really getting the flux in the inner ring of that core, but you can still use it. It's okay, but you're just not penetrating the entire iron core. So you got to keep that in mind. That changes things. So, but if you have it vertically, like in a transformer iron, that's one of the reasons we switched to using regular transformer steel, is because the laminates are vertical. So it's much easier to introduce a magnet that's smaller and weaker and put it in line with the iron's flux so that the isolated iron sheets can be all independently saturated by that permanent magnet. So but you could do it a lot of different ways. You can even cut into a ferrite ring. You can take a ferrite ring and with a grinder and stick a little magnet in there and make a MEG that way. And you can sand a flat on the two ferrites and put it together, and then or glue it together with super glue, and then now you have a 2-ring MEG right there, just with a sander and 2 ferrite rings. You can build a MEG like that. You can make a 3. You can do 3 rings, 6 rings. You can make make a 6-phase transformer with a sander and a couple ferrite rings. You can even put a coil in between each leg, so you that helps hold it together. You can make a MEG that way. I mean, a lot of different ways. The very first MEG was actually a straight linear iron core. It wasn't a ring or a loop. They left it open. Yeah, when they were experimenting with it, they left it open. That's how they verified the effect was real, because you couldn't explain the way the end of the magnetism on the end of the bars was reacting, because it had something to do with the reluctance and then the path that the magnetic field was allowed to take. Because you switched a magnet on, the magnet would actually, it was like you could switch a permanent magnet's field direction, and it would actually stay the other direction until you switched it again. So you could, it was pretty interesting effect. And that was one of their first. It's still on YouTube. It was Tom Bearden's MEG, but it wasn't Tom Bearden in the video. It was one of his partners. He shows you that effect on that video. I think probably y'all seen it, but yeah, he shows you the effect of how you can have a permanent magnet introduced in an iron core, and you could have it T. So it's teed off. So one pole has 2 paths it can take, and then you put a coil on each path. When you energize one of those paths, the magnetic field will try to stay in the other side, even when you switch the field off. It's got a little bit of memory effect, so you can use that to your advantage in a motor, or you can use you could leave it open to where it sloshes back, and then use that to slosh through another coil, and then that's how you collect. One of the tricks to doing this is think of you want to create a change in a system. So that means an instantaneous change. So instantaneous pulse, PWM, instantaneous change. Instantaneous change in a magnetic field is a change in the electric vacuum itself, because it is one and the same. That is the vacuum. Every magnetic field is the vacuum. You're holding the universe's power in your hands when you hold a magnet. That's what it is. The magnet's not emitting anything. It's redirecting the universe. It's kind of hard to explain because we're humans, right? But that's what the universe is providing that field for you, since you set that condition up when you charge the magnet with a giant field. Now the giant field stays for free forever until it changes or time goes on, because it's aligned. That's the only thing you had to do was align the atoms, and it does this for you. Energy just pours out. It just recirculates in itself, and it creates a static field. Yeah. So you got to think about it like that. So you have to, and then find ways to use it to your advantage. Like in industrial settings, like where I work, because I've been a welder my whole life. I've used lifting magnets in the industry that are OSHA certified to lift 2,000 pounds overhead in a shop safely, to move plates and pipe and material, and they last basically forever. They don't create heat. They don't need power. You just have a lever, you turn it on, and you turn it off. And when you're done, every year they get recertified. They brake test it, and they brake test about the same every year. Depending on the temperature at the time in the room, it's going to do about the same every year. So unless you drop it or it gets hot, from like sitting out in the sun, or you get hot with a torch on accident, or you weld next to it, that'll demag it. But other than that, you've got a permanent lifting magnet that lifts the same amount of weight. I've used some that are over 25 years old that are still recertified, that they've just been taken care of. And you can suspend stuff pretty much forever. I mean, you can suspend a couple 100 pounds and just leave it on a crane, and it'll sit there until you put it down. Think about it for a second. Like how is that? How is that, man? Like, how is that you can charge something one time and now you can suspend something against gravity indefinitely? You know what I mean?
Well, it's interesting in the way that you describe it, though.
Yeah.
It's the universe that gives you the energy. So when I say the field, or I say the room, it's like the same thing. It's energy's out there, and you just got to set the condition for it to take it in. And it's not any different than a magnet, but you can't build it with the heat of into your magnet like we do with all of these, coils and stuff. We have to build it with the cold in the magnet, just like the magnet is originally when it's sitting in your hand. It's as cold as the room temperature, and then if you want to get more energy in it, you just got to get it colder. It is no different.
So remember when I talked about the Peltier type effect that happens in some of your systems? Some of you have already stumbled into this. You've described it to where it's getting cold. Things get colder. It doesn't make sense, right? You're putting power in this thing. How's it getting cold? Okay, now what if we could set that same condition up electrically on a material that does become a superconductor? What do you have then? What do we have then? Because you already got a way to make something super cold with electricity. So what else can we do with that? You ever think about that?
Well, that's why we want to try a business, because we believe it has a huge spike, and then we can really get into superconductivity.
Yeah, and some other things happen if you can align those molecules with an electric field while it's cooling. We might talk off air more about that. But there is some videos on YouTube. I'll go ahead and say what it is. It's called an electrolyte or something like this.
Oh yeah, Jarvis is building them.
Now, I'm surprised that is actually being talked about. Let me say that. I'm extremely effing surprised that made it out. I can't believe it. I can't believe that they let that out, that they allowed that. I just can't believe it. If you guys only knew what you could do with that, you would just poop all over yourself, man. I'm telling you. Because you don't have to just use plastic, guys. Think of everything else that's conductive. I'm not conductive. Sorry, it can't be conductive. Has to be naturally dielectric, an insulator. There's a lot of materials that are more capacitive than plastic. Now, I'll let y'all think about that. I don't want to go too much more into that. I'm at a line right now, so I'll let you think about that. Do some research. There's a guy that made some kind of battery he talks about online that's powering a helicopter headlight. He calls it a solar battery. You might look into that and look at those plates, look closely in between them, see if you see anything at all. Maybe it's clear, maybe it's not, I don't know, but you can look at that and think about it. Think about what you have right there.
Well, like I said, Jarvis is building them. Another guy,
yes,
he's building them. He's got a patent for them, and him and Sean are really going into it.
Yeah, I know. The plasma channel, is that who you're referencing?
No.
No? Who is this again? Who's this?
Jarvis. He's an engineer. You'll see him in the chat as Mr. Lanius. He comes over all the time, man.
Oh, okay. I don't know. Yeah, I didn't know who that was. Sorry, dude, if you're listening. It's not my. I'm busy, man. I don't look at a lot of stuff online anymore. I'm so busy. I have so much of my own stuff to do, man. It's a lot.
No, I get it.
Like I have to take time just to watch the news because it's so crazy right now. But that's the main motivation is because it's entertaining right now. But, yeah.
Well, that's
Yeah, y'all
cool,
need to play
man.
with that, man. You need to make some of those. And you might think about, Nathan, you might think about, what if you did put something like that in one of those, your flyers? What would happen?
Well, I'll tell you
What would happen if you put a
do.
permanent static field in the core of that device? What's going to happen?
What do you think I'm trying to do?
Mhm.
Yeah, I'm definitely putting a permanent static field in there because the static field.
Yeah.
No, you got to understand how the field's built. As soon as you put
Yeah.
in that radiant energy, man, you're trapping that static field, and you want to trap it in layers. That's the point. You know what I mean?
Yep. Well, you're slicing it a different way then. Yeah. Yeah, you're slicing the apple a different way. Yeah. Yeah, you could do that.
I want to look into bismuth because I want to see exactly what it's going to do in this system, and I want it to grow in exact frequency. So the first thing we have to do is get the spheres to turn, right? Turn them, check the frequency on them, then set the condition in the bismuth as it's drying super fast, right? So you want to set a condition where it super cools, but it has the frequency in it already. Now,
I know exactly what you're talking about, and it's like nano.
Yeah, I know. You're making a cavity. You're making a resonant cavity. I'm talking more solid state.
Monoatomic bismuth to do exactly that.
Well,
with the layering.
It's like all worlds wrapped into one, and we're going to see
so
how it works.
as you seal it in like the epoxy on the layer, as you put the monoatomic in, you run that frequency through it so that it's all aligned, and then you have it permanently sealed in it like that, and how you manufacture that layer.
Because hot voltage structures, but cold voltage destructures. So that's why when it runs through water or anything like that. So if you set up the condition in the water, you get the frequency, you can actually set it up and it'll create little veins inside there of exactly the frequency that you want.
Yep.
And then it sets a condition like your Earth and the fields that we got going around it.
Yep.
So it's just interesting. The ley lines is what I'm basically setting when I do it.
So that's part of it too. So there was a couple patents that got the security orders put on them, and those were electrolyte related. And those type of systems do work better in certain areas on the planet.
Mm-hmm.
They do. Much better.
Well, think about it. I mean, what's the difference between your magnet and an electret? All you're doing is changing volts and amps. That's it.
Yes, that's basically in a nutshell. Yeah, electrolyte is a dielectric magnet.
Yeah.
You created a dielectric coherent field. That's all it is. And you can tickle that in certain ways if you put plates on it. That you got to be careful with it, but yeah, you can perturb it and take a little bit, and then you can take a lot, and then you got something. And like if I built one, I don't actually plan to build one of those, but because I have too much stuff already. But if I built one and I had it at my house and it was giving me like say 100 watts, and I shipped it to you, your house, it might give you 400.
Mm-hmm.
It's just the way it is. Like it's just where you are relative to where it can collect. So it's actually solar powered. Technically, it's solar powered. It just doesn't need to see the sun at all.
Because
it's collecting the field that the sun provides us. So it's collecting off of that. Yep, because the conditions set up in the material when you created it.
That's what I mean. You're setting a condition. Now the environment plays
got a
role.
permanent condition. That's a solid state permanent condition. Okay. You can do a lot with it. We'll say that. You should also put it on a scale and see what happens when you create it and it's not created. Like before and after.
It's interesting.
Weigh everything before and after. See if you notice anything.
Yeah, it all pretty much works the same. If you have the key to understand what it's doing, you've got it.
Mm-hmm. Yeah, and then measure the weight with a sensitive scale at different times during the day and different times during the lunar cycles. Do this, and you might be surprised.
I'll have to try that. I've always wanted to try it. I'll have to try it.
Mm-hmm. It's simple. It's actually extremely simple to make. The main thing is, if you want to make one out of plastic, you have to avoid anti-static. You have to avoid anti-static, which is titanium dioxide additives. You got to avoid those. A lot of Lexan has it in it, so it's anti-static, so the plastic doesn't hold a static field. That won't work. A lot of plastics have that added. You have to look. Acrylic, some acrylics don't. You can get virgin Teflon, PTFE, that doesn't have it. Sir, you have to look at the charts and stuff if you actually want to make one. There's even simpler ones. There's a certain wax, I think beeswax or something like that. There's Carnera wax. There's one you can make. That's how they did it back in the day. Back 100 years ago, they made these. So,
yeah, Plasma Channel, I think, started out with beeswax or something like that.
Yeah, he did what they did over 100 years ago, basically.
Yeah.
They've already done this. Like, they already did that. It was just not talked about back in the day. They didn't want to talk about it with everybody. So, and I think I know who discovered it, at least initially, out of another material. I can't remember his name right now, but they were self-running a network analyzer. Tom Bearden talked about him. I might remember his name, but it was at a university, I believe. They were running a network analyzer off of what they called the negative resistor, and I think I know how they stumbled into that. I think what it was there was some old school resistors in a box or on a board, like an old board. Think back in like early 1900s. So their stuff was old, man. They used glass, they used all kind of materials to make resistors and stuff. So if you have a box and you're using high voltage, it's the early 1900s, and you don't really know what you're doing. Everyone's experimenting. Like Tesla was like they knew what they were doing. They made the first theories, but they were experimenting with everything. So they were. What I think happened is they had a resistor network, and the resistors got hot. There was already an electric field present, so you had an E field present that never went away, and the resistors got hot. They were able to cool down slowly in this condition, and then they realized that, the resistors are acting weird. This ain't working no more. Something's weird. And then they go to check stuff and measure it, and they realize there's a small voltage across this resistor now. That's weird. How come I have 0.7 volts across this glass melted resistor? And then once I think they realized what they stumbled into, they made a big box with them. Now think about that for a second. Yeah. Now you're dealing with some pretty high voltages, so you got to be careful. But one way you can change it is tap it into a transformer, a high voltage transformer. Tap it into that. Just tap it, make a capacitor out of one and tap it into the transformer, and then make a lower. You can increase the current significantly by doing this and change the voltage to a usable, and it's transformed because you converted it to a magnetic field in the transformer, and it's been reconverted back into an electric field on the other side. So now you have real power with, you're going to have a little power factor change, but you still have real power on the other end. Because it's a transformer. You're creating a change in the transformer. So that's that's all you got to do. And especially you could make it kind of AC if you chopped it just right. You could do that. You could do a single impulse. You could do a lot. You can collect off a single, no problem. And you can even collect the back EMF off your impulse and then turn it back around, put that back in your system or in another transformer, and have a couple loop systems going that are in resonance. All running off your thing you made.
That's right. No.
Yep.
Spark caps are important, man. More than people realize these days.
Yes, the spark gaps are good because you know why? Because a spark gap can give you an instantaneous change extremely simply and easily. And you can increase the speed of that change by adding a magnetic field quencher around it. And now
Right.
you've increased essentially the velocity of the field change, because now it's got to jump extremely fast because the magnetic field's holding it back a little bit and it's squeezing it down. So it's going to jump extremely quickly at full power, and that's how you can do stuff too.
Well,
That's what Tesla was doing.
Yeah, so it usually blows out all your MOSFETs and transistors.
Yeah, it can actually be dangerous, so you got to be careful with that.
That's why you use a spark gap instead, so you don't have that problem.
Yeah,
You're going to get massive voltages and stuff.
Well, no, even with the spark gap, if you go too big, it can kill you if you're within proximity. It did that to a lot of operators that were switching on DC power generator stations back in the day. They were unshielded and ungrounded. So when they closed the switch, the dielectric field impulse, the longitudinal pulse from the wire, killed them.
Oh,
yeah. And they were at the switch. They weren't even by the wire, but they seen the glow, they seen the dielectric lines, and it killed them. And then they were like, oh, that's not good. So they started shunting it and stuff like that to help. And that is your instantaneous change on the wire. The wire is resisting it initially in time, and that's where the pulse comes out, because the dielectric field moves. The electric field is set up almost outside of time, like it comes on all at the same time in the circuit. It's once it's closed, it comes on like at the same time. So, or all around the wire, even if it's 100 miles long. The field will come on at the same time. It's almost like entanglement. So, yeah.
That's why they started dumping stuff into the ground. They started grounding their system.
Yep. And that saved the operators. It kept them from dying. So that's one of the reasons they did that. Yeah. So if you do experiments like this, now you're not going to do that with little bitty coils. You're going to have something like Nikola Tesla had set up, where he's sitting down reading a book and it's like 12 feet tall. That's what's going to hurt you, not your little bitty stuff everyone plays with, because we don't have the room. I mean, and you might have the room. I don't have the room for a 12-foot coil, or the copper or the money. But if you did, that's where you need to be extremely careful, because that can kill you, or it can injure you. It can injure your neighbor. It can injure animals. It can injure a lot of things. So you got to be careful with that. Yeah, because they did have a problem with it early on, switching DC generators on. Because there was an instantaneous change on the wire. The wire has an inductance, which is essentially a virtual resistance. So, and that creates a buildup, and then that's where the pulse comes from. Not necessarily comes from, but that's what part of what creates this problem, or quote unquote problem.
Yeah, that's why you shut down everything in your house when there's a power outage, and then when it comes back on, then you turn everything back on.
Yep. You got to be careful when they turn it on.
Yeah, you're taking the life out of your appliances and everything by leaving them on.
Yeah, just kill the main and then wait for your neighbors to ruin their refrigerator. You know?
That's right.
Yeah, that's kind of mean, but yeah.
Leave a light on outside, and as soon as you see it go on, it's okay to turn everything on.
Yeah.
Yeah.
Man, I'm excited about my heat pump video I'm going to make, because that's a good one for people, because you can make a DC air conditioner in like a small cabin or something is effing amazing, because it's super efficient and it's free and it always works because it's solar. You just got to have a little battery bank for it, but you don't need much for one of those. Like a 200 amp hours will get you almost through a whole night with one, especially if you put it on low. It will definitely get you through a whole night.
Nice.
Or with heat, yes. So it's great. And like if you had a lab, you could set a few up in your lab just to take the edge off in the summer, or maybe to give you some heat in the winter. It's free. It doesn't come off your power bill. That's one easy way to do it, because all refrigeration or air conditioners is over Unity. So there's you go. There's plenty of opportunity everywhere with material effect. You can do it with everything. You can do it with permanent magnets, make a permanent magnet motor. If you want to go that route, you can do it a lot of different ways. So, yeah, MEG's not the only way. Like a lot of people I know, they look at that like that's probably the most likely to be real. It's not the only real one. Like there's a lot of real ones. They're just all over the internet now is a bunch of garbage. Pretty much, it's embedded everywhere, and they did it's on purpose, so it confuses you, makes you think it's not true. But you just got to investigate yourself. That's the problem. Is like people believe what they see, and they won't test it, and so you don't get any discoveries. Like you're not going to innovate or ever discover anything for yourself anyway, if you rely on stuff like that. Like I want to have a couple of patents eventually, but they won't be in this line. There'll be something else, like a product maybe, but that's kind of different. But yeah, you can come up with your own ideas. Like you can. Everyone can. Everyone's capable of this. They want to.
Absolutely.
Yes, just try. All you gotta do is try. No one's stopping anybody.
I dislike the people that come on and always tell me the same thing. Oh, you're just doing this, you're just doing that, and this is all that's going on. Well, did you build it? And if your answer is no, then you have no idea what I'm doing.
Well,
you won't even be close to sniffing my fart on what I'm doing. It's bad, dude. Like, I do so many crazy things with this stuff that they think they know what's going on. They just have no idea. They're not even close to it. They keep citing the same, BS garbage every time. And the answer is always on the other side of it. And they try to fact check you. And it's like, dude, you did a poor job because you don't know what you're talking about because you haven't run it. I see it all the time, man. And they just don't understand what's going on. They have never seen the effect. And because they haven't seen it, they always try to do, this was this effect combined with this effect. Well, no, it's not. It's really not. It's something totally different. When you create a radiant energy, you'll know it because it won't act the same. It'll act like a gas. And you're going to go, well, how come I can't contain this? How come it's going everywhere? How come it's going through everything? Like, I put mine right through burritos, man, and use them in a chain and can chain them up forward long, man, to light up another Tesla coil. I mean, seriously. You can't do that with regular energy. It doesn't work that way.
Well, there's a lot going on, man. I forgot what I was gonna say. The burritos lost me. Made me think about burritos. And then I'm like, damn, I'm kind of hungry. And then I'm like, fuck, I lost where I was.
I got one little video of a permanent magnet motor up demo that I'd like you guys' opinions on if I think this is.
Yeah, you could run it real quick. My old lady went to go get her son, so I got a few minutes for sure.
Okay.
All right, so very simple to test.
Yes, I think you can do that because I have a few in my archive that I know work. I'll say that I know they work, but balancing that is pretty tricky. You got to get it
it's just
spaced right.
Angles.
Everything's got to be just right to do that. Yes. That's not the only way. You can add a cam action. I don't know if this one's real. I'm trying to see. They do have some of the magnets right, but it's hard to say. Because there is some fake ones, but the real one, like one of the real ones is on my channel. It's the wooden one. I know that one's real. That's an old model too. That's been around a long time. And anyone can replicate that as long as you're willing to be patient and actually try. You will eventually get it to work. It'll be daunting because you have to heat magnets up to get it just right. Like it's tricky getting the forces balanced. A lot of people will just slap stuff together and say, it doesn't work. But you didn't engineer nothing. Like you didn't do anything. All you did is took 30 minutes and tried, and now you failed. So, but you've never even engineered anything before. So it's like you haven't really tried as everything you could. You know what I mean? Like the people could try more stuff, and then you'd be surprised what you find out. Yeah.
Interesting.
Yeah.
Right? Just have to.
It could be
experiment and replicate yourselves and.
Let me look. I don't know how he's facing them out.
He's only pushing in one direction. That's
no, I don't think that's real. No, it doesn't look like it's gonna work like that. Well, hold on. Let me look at it. No, that might actually work. If he's pushing. he's doing a push action. And maybe he did balance that. Yeah, no, you can do that. Yeah, you can push it, and gravity will even help a little bit as you're pushing it down. Yeah, it might be, but that air gap's critical too to spacing. And I don't know what he's got going on up there. Oh, that's just a pin. Yeah. I mean, it could be, but those angles that he's got, I bet you it took him a long time to find just that on that. Whatever the drive part, the drive arm.
It's a critical one. I think it's off of another YouTube channel.
Yeah, I mean it's hard to say.
Yeah,
You'd
right?
have
So
to
it's
try
like,
it.
does it keep running? Because when he pushes the arm in, it right? Because it's like
the one I know of will.
That's what gets it spinning. It's the question of does it keep spinning, right?
Well, it's okay to add a little energy in at first. There's nothing wrong with that. If the inertia and momentum helps it stay running too. Because you can jump start it with a hand crank, you can jump start it with a solar panel and a battery, you can jump start it solar panel and a capacitor. There's a lot of things you can do to have a start button on something if all you got to do is get it up to a certain speed. So I wouldn't be afraid of that of a starter, but I do know that there's the wooden one will keep going. It will keep going and going, especially if it's balanced right. But you just can't collect much off of it because it doesn't have a lot of momentum. So you're not going to even get 1 watt.
I think it's proof of concept. I don't think they were looking.
Yeah, it's proof of concept. You're not going to get much more than a watt. You might get a watt if you're lucky, but it's going to be in surges because you're going to have to collect and let it recover, and it's going to suck. It's not going to be worthless. You're going to waste your time. Other than a shelf piece that's cool. But yeah, eventually it will demagnetize. It'll probably demag in, it's hard to say. It could demag in 20 years. It could demag in 100 years because it's actually in action. They're doing work against each other, but the material hasn't changed yet. But as it ages, it might start to change slowly to where the parameters change outside of the range where it'll originally work. So you're going to have, it's not going to run forever, ever. But as far as you're concerned, it's about like a nuclear reactor, but sometimes not quite as good because you can wear them out quicker. Depends on how hard you want to push it. But if you push it real hard, it'll exponentially ruin it. But if you don't, if you take it easy and oversize it, you can get something to last a long time. Almost indefinitely as far as the magnet's life, because you can tap on it to where the permanent magnet isn't really stressed much at all, so that you're not really taking away much from its life at all, if any. But you probably are a tiny bit, but it's negligible. I mean, who cares? If you've got a couple of magnets sitting on a shelf that's going to lose 1% over 100 years, and the magnet in the machine loses 50% in 20 years, who cares? You've got enough magnet battery there for the next 500 years. Do you understand what I'm saying? That's the reality.
Oh,
yeah, so it's not necessarily completely free because everything experiences neg entropy eventually. But when you're taking advantage of material effect, materials last a really long time, especially stable elements, like we are, right? So if you can take advantage of a material effect while it's still within its life and it's stable, it's you have it. That's what life is. I mean, life is a self-sustaining operation. I mean, it's everything. I mean, right there in front of you.
On that motor.
Yeah.
Honestly, if they're not pulling energy out of it, I'm okay with it. It's when they start trying to tell you that they can pull energy out of it, that's when I get concerned. That's when they're trying to pull some wool. You know what I mean? But if it's just self-running, something like that, lightweight, there's no problem there. You can make something work like that.
Yeah, the moment you apply a load to one of those that's finely balanced, you're gonna slow it down pretty fast.
Sure.
I don't know what speed you would, or what gear ratio, or what you would have to do to collect what you could collect, but it would be so small that you wouldn't even charge a phone with it. You'd probably light a LED. Yeah,
well,
you'd probably do that.
It all depends on how much it turns, and if you could put magnets on it on the outside with a coil on the outside with no iron in it. If you put aluminum core instead of the iron core, you could probably get some electricity out, but it'd be very small amounts. Like maybe an LED strip or something, but not much more than that.
Yeah, you could though. But the thing is what's kind of cool about those little systems though, still, is they can trickle charge something over time. Because think of all the objects that are just laying around your house, like your TV remote, or if you're thinking solid state now, you're taking the same concept there and going solid state with a ringer. If you have that in a TV remote, you have basically an eternal TV remote. You know what I'm saying? But as far as that, yeah, I mean, you could collect a little bit. You could actually collect off a permanent magnet motor if it's big enough, because the Howard Johnson motor, there's a story I was told by somebody that if you were to try and order those magnet dimensions from a magnet company to have them made, that you might actually get some bad people to come visit your house. I was warned that by a high level person. Don't try to order the Howard Johnson magnets, because you will trigger an alert, and at least back in the day, back in like the early 90s, they would send somebody after you.
Really?
Yep. Because they would already know that you're what you're getting into, and they're just, yeah. Because he told me there was a lot of people killed that did that. And I won't say a lot, but there was a handful of people that got taken out because all they did is submitted a precise dimension request that matched exactly the Howard Johnson magnet design. And yeah, it triggered something that occurred after that.
Well, now they sell magnet machines that you can magnetize your own magnets with.
Yeah, but it's the shape and stuff. Like a lot of people, especially back in the day, they didn't have the equipment to make those specialty shaped ones. Because I don't know if you know what they look like. They look almost like an airplane wing. They're asymmetrical and they're very unique. And you have to have a machine to make that. So unless you have that machine and then you can magnetize it, then yeah, you could do it. But if you don't, you have to order them. That's when it happens. Most inventors can't make it like you're talking about. And they never have. If they have, they're completely silent, and you're not going to know about it because they're still alive, maybe. But the ones that have ordered it are probably not still with us. So to tell their side of the story is what I'm getting at. So it's pretty serious. Like, I'm not joking either. The person that told me that has no reason to lie. He's over 70 years old, and he's helped some governments do stuff. So yeah.
Oh, wow.
He warned me explicitly about it.
Stay away from some magnets. That's good to know.
Well, no. Just don't broadcast to the world exactly what motor that was proven to work at shows that you're trying to do. Because it was like a 1 horsepower, 1.5 horse permanent magnet motor. What could you imagine that? That's 1,000 watts. Yeah. So you're going to another level. Anything that's over, like anything significant like that, that's worth them sending a crew after you, is basically what I was told. So yeah, it's worth it to them. They will do it. Like, it's not a joke. If you stumble into that and you start broadcasting what you're getting into, especially if it's significant, you're going to get a visit. At least in the past. I don't know about now, since some things are changing right now. I don't know. Those people that would normally be doing that are now private, or they're looking for a job. So luckily, we're at a good time to talk about this.
Yeah, no kidding. No, they're getting rid of all of them.
All the goons are busy. They're looking for a job. Of course, there might be some goons left over, but most of them are gone. They took the deal. They took the fork in the road, man. Yep. Email, because all the CIA agents got that email. So anybody could have taken it. But not everybody would have been allowed, because some positions are highly sensitive. But those would have been like, no, just kidding, give it back. But for the most part, about 80% of their staff's going to go. So only the high level people are going to be left, and they're not going to have enough time to look at us. They're just not. It's not worth it anymore. There's going to be way bigger fish. They're worried about China. China has already infiltrated our infrastructure, so it's like that's a problem, and they can't get them out. They've already admitted it on the news. The FBI had to admit it, and then even though there was probably something else going on.
Yeah,
we just
probably.
didn't know about. But yeah, probably most likely true. But we'll see. We'll find out in a couple months. But yeah, maybe we will be able to actually get them out now. Now that we got some brains with AI technology helping us out, maybe we can actually kick them out. Maybe we can outsmart them at their own game. You know what I mean? The Chinese and other adversaries that are hacking us. If you don't use encryption, man, you're basically, when you say I love you to your wife or husband, you're telling the Chinese too. They're seeing it too. They're thinking good morning too, because they're intercepting every damn message that's going through. If it's an Android to a Samsung, they are intercepting it because you're using the most basic telecommunication system network that still exists to do it instead of the internet through an encrypted means. When you make a phone call, even that is intercepted. It's not just the FBI and CIA that can tap your phone anymore or turn your mics and cameras on. It's the Chinese and the Russians and more. There's other countries that can do it. It's not just them because they help other countries too. They've helped them out. So what do you think? Who do you think else can do it? With our 1995 technology still being used, every modem in every phone used today has the same chip that uses that network on that modem. So you're screwed. You can't change it.
That's the whole purpose of the Five Eyes. So they spy on each other with,
Of course, man. And you know, America's a democracy. It's actually a republic, but we can call it whatever. It's a free country, right? So freedom of expression and speech, that creates a problem. It creates a big problem when you're trying to have a military that's strong, because you have to treat your civilians almost like the enemy, because when you broadcast to the civilians, you're broadcasting to the enemy. So what happens is you end up getting a mixed signal because the military is trying to broadcast something to someone else, but it looks like it's to you. So it's really conglomerated. That's why the Chinese are doing a lot better than us right now, because they have full control. They don't care about any of that. All their engineers live on site, so they don't even leave. So they don't care. They don't care what they think. They're not ever leaving the facility. So in their life, or their kids or anybody, they're all going to live there forever. So who cares? They don't need to worry about media or lying to their people. They don't. They're silent. They can be completely silent if they want.
No, I agree with you.
That's the only downfall to a democracy or republic. And I love it. I love it here, but it's like that is an issue. And you have to recognize that that's the position they're put in, because they can't do it any other way. You can't be the number one superpower for 70 years and not and operate without having deception in your stuff, because you're a democracy. Everything the civilians know, the enemies know, plus more, because they intercept your signals. So when something comes on the news, the Chinese look at it before you do, because they intercepted the signal before it even gets to your television. Their AI's already downloaded it. So their military leaders are seeing it before you. So it's like, and they know this. So it's like they have to deceive you a little bit. Or else we're going to be dead. We're going to die because we're giving away all their secrets, and the enemy knows, and we don't know what they're doing because they're not like us. And not entirely. Russia's like a blend of communism and democracy, kind of. So they have more control in some aspect, but they don't have a lot of money. So they have to rely on their neighbors.
Yeah, crazy out there, man. Well, that's why I usually just stick to playing with electricity.
Yeah, you got to stick to it, but it's interesting too, because like the drone situation was a very interesting time, because there was a lot of recordings that was really cool.
American.
A lot of those are ours. Not all of them
they
were
all
ours.
were, and it was like, of course they were.
No, not all of them.
American bases.
Not all of
they
them.
Shot down, if not.
Well, some of them. Some of them were not American.
Got shot down.
I'll tell you that much. And ours were a response to that. So about 95% of what you saw was ours, but that wasn't. There was 5% that was not ours, because that's the whole reason they got out in the first place. They wouldn't have done that if there wasn't something significant going on. You're talking about acing the whole technology being just laid out in the open right on top of the interstate for a week straight. Why do you think our government did that? Think about it for a second. Step back and really think about why would they do something like that? Break out all our aircraft, all our special shit, and just leave it out there without cloaking, nothing. And then they're also showing off. They're doing their tricks and stuff up there, making jet sounds and looking like this. And now I'm changing, looking like a ball. Now I'm doing this. They're showing off. Why would they do that? How would they demonstrate capability?
Well, they already tried to shut it down because Trump just went out and said they're all drones from people flying them and other stuff like that.
Yeah, well,
so
they have to. They're not going to come out and tell you everything.
They're already covering the tracks, whatever it was.
No, the Trump parroted the same thing Biden said. Other than admitting that they're ours, they're not the enemy. That was all Biden really had to say. If he would have said that, most people would eventually shut up and just went to work. They would have forgot about it. I mean, they would have looked at him, but they wouldn't be shooting at him. They wouldn't be worried about him as much. If they would have just admitted, hey, this is our experimental technology. You can look at it if you want. Don't worry about it. Just fucking go to work and chill. And like that would have calmed everybody down. Even if a lot of people, you'd have some people, I don't buy it. It's aliens, whatever. But for the most part, it would have calmed the population.
No, I understand.
So that's a little weird, but no, I think what happened is someone else sent some stuff over just to probe because they knew they had an opening and they just wanted to see what we would do. And we had a pretty strong response. So, because they had everything out. They did everything. They had HARP. They were using HARP. They were using every technology they have. Almost, maybe not all of it, because I didn't see all of it, but I seen a lot of it. I seen about 70%. Yeah, I'm about to have to go because how long have we gone? Almost 3 hours. Yeah.
Yeah. No, I get it, man.
She gave me the look. She just got home. Yeah.
I understand.
Yeah, but y'all should.
I'm doing stream with Alien Scientist, and it was great to meet you. Listen, and
Nathan, yeah. No, I'm not an alien scientist. I'm just a guy trying to make motors, man.
Yeah. Hey, motors run the world, so good on you. And so that's what we're all trying to do here is power to the people.
I love making stuff, man. I love prototyping, just like Nathan. It's fun, man. It's fun seeing your own creation work and stuff.
That's right.
But all right, guys. Thanks for watching. Thanks for letting me on. I appreciate it. It's always a pleasure, man. It's nice to meet you too. I didn't get your name again. I can't even see it. Where'd he go? He's gone. Okay. All right. Hey, see you guys later, man.
Have a good night.
Hey, you too, man.
Thank you.
All right,
Thank you for coming on.
No problem, man. Good times.
So real quick, before we do anything else, I just want to say thank you to Tim Adams, man. Thank you very much. I really do appreciate that. That's awesome of you.
Yeah, that was really cool.
And then I wanted to show real quick, if you don't mind, Ben. These are the new people that now have memberships on the channel, man. So
nice.
Right on, man. I hope you guys enjoy the content. It'll be awesome. So I got a bunch more stuff to put on there. While I'm working on this stuff here, it sounds crazy, so I can't do any videos. So I've been translating a lot of PDFs to voice from AI. So,
well, what you're really working on now is going to prove to be your piece de resistance.
Yeah, well, it's gonna be something, man.
I can't wait.
I'll tell you that. I certainly didn't hold back. You know what I mean when it comes to money and stuff. Oh, right on, man. Appreciate it. Another membership gift is right on. So, yeah, man, we got all kinds of cool stuff coming up, Ben. You got anything going on with your stuff?
Right now, the only thing that's going on with me is I need to take time to fix my 3D printer. So it's not yielding any results. I have to swap out the old board, and that's probably what it is. And I'll probably just have to desolder the encoder off of the new board and put it on the old board. So I need to do that. And we probably will have a live stream with another interactive mini lab where I will go from start to finish building a Lightning Thief PCB, where I'll show you, live on stream, me soldering the connections and building the device and putting in the case and all that stuff. So
Nice.
that'll be fun.
By the way, Angel, I just want to say thank you. So, yeah. Well, Ben, when you get a chance, just hit me up. We'll do a StreamYard on that printer because it's probably easier than you think, man. Some of this things, they give you a false reading, and it's really something simple. So I've torn these things apart, man. Like I said, I got a bunch of these.
Yeah, it's weird because the screen works perfect, but yeah, we'll see. Well, I'll email you. I'm gonna swap out the new board for the old board just to double check, just to be sure, and then we'll go from there.
Cool. Right on, man. Well, it's been like 3 hours, man. So it's time to get going. Man, we had a great show today, Ben. It was really awesome, man.
We went an hour into overtime almost.
Yeah. Well, when you get a special guest on, man, that's what you got to do sometimes. So,
hey,
right on, everybody. I want to thank everybody in the chat. You guys have been awesome tonight. I try to put up as much as I can, but when I get in the conversation, it's a little hard. So, thank you, everybody there. Thank you, Ben. Thank you. What's that name again? I can never pronounce it.
Coils? I just call him Coils.
Thank you, Heliarch. I really do appreciate it. Always look to Ben for help with this.
Heliarch?
Yeah.
There's a couple of names you got to watch out for.
I keep wanting to say Hilaric, and I know it's wrong. It's Heliarch. It's just a mental thing, I guess. Right on, everybody. Have a great night. Thank you.
Yes, thank you. And thank you to our new members.
Yes, thank you.